Welcome to the third episode of our Webinar Wednesday series. I'm glad to see a lot of you are still joining us, and I hope that you've been learning a lot these past couple of weeks. My name is Jen Paffenroth. I'm the administrator at IEC Thermo. We have another really exciting webinar lined up for you today. If you were unable to join either of the first two webinars, Hemp Drying Basics or a virtual tour of an IEC hemp dryer, be sure to check them out on YouTube. They're really informative and cover lots of different hemp-related topics. So be sure to subscribe to our YouTube channel, IEC Thermo, as we are continuing to add more and more content. Next week, we will have a panel of hemp farmers who not only have been successful in the hemp industry in 2019, but they also own and operate IEC Thermo hemp dryers. They'll be talking about things they learned this past year, their experience drying hemp with an IEC dryer, and a lot more. They're a wealth of knowledge, and I know it will be a really great episode. You can register through our website, and we also have an event on our Facebook as well. And today we have three members of the IEC Thermo technical team, Ben, Chris, and Alfonso. And they've all spent a lot of time out in the field and have lots of technical insights about hemp drying. As you think of questions throughout the presentation today, feel free to type them in the Q&A section, and then Ben, Chris, and Alfonso will answer them at the end of today's webinar. We'd actually like to start off with some new news we have. So on behalf of the IEC Thermo team, I'd like to read a press release, and then Alfonso, Ben, and Chris will dive deeper into those results as well. It's no secret that terpenes play an important role in cannabis and hemp. Terpenes give cannabis its flavor and smell and work together in profiles to provide a balanced and therapeutic effect. Terpenes can be used in conjunction with cannabinoids or by themselves to provide a number of health benefits. The importance of terpenes is slowly becoming the popular narrative. While the value of terpenes is undeniable, the question remains on how best to stabilize and extract terpenes. Fresh hemp has the highest quality terpenes. However, almost immediately after harvest, hemp biomass begins to break down until it is stabilized by drying. Terpenes, on the other hand, are easily damaged by extended periods of high heat, meaning most terpenes can burn off during the drying process if not carefully monitored. Even during hang drying, there is some degradation of terpenes. While it is impossible to collect every molecule of terpenes, we at IEC Thermo have made some very exciting steps in this direction. There is existing equipment in the marketplace that is designed specifically for the extraction of terpenes. However, this can be an added expense and an extra step that not every farmer or processor can afford to make. Luckily, you no longer have to choose between quickly stabilizing your crop and preserving your terpenes. IEC Thermo is known for our CBD-friendly hemp dryers with 90-second dry times and low temperature operations. Our patent-pending process is recognized to be gentle on hemp and cannabinoids. New studies have showed that IEC hemp dryers also help preserve terpenes too. So we conducted a study in conjunction with Iron Laboratories using 4 different samples of shredded hemp biomass, and I'm going to pass it over to Alfonso, Ben, and Chris now, and they're going to break these results down for us.
Yeah, so as Chris pulls up the report, we'll just wait a minute, and then I will cover in detail and just outline the report. All right, so we'll dive right into the report. So right here we can see that we're looking at a analysis, potency analysis conducted by Iron Laboratories. This was done using high performance liquid chromatography. So side note, if you would like to follow along with a full copy of the report, that QR code on the top right is live. So feel free to scan that with your camera, smartphone, and you'll pull up the full report. It's a 2-page report, and we'll dive into that as we go on. So as we follow along on the top left here, we see that this sample here is of raw wet feed. So this is in fact wet material that came into a facility from a baled product, right? So fresh off the bale, we're looking at moisture content on the top left of the report at 70.84%. We also went ahead and conducted a water activity report. What water activity does is it's a ratio of the water vapor present in the sample over the water vapor of pure water, or the vapor pressure of pure water. So anything that scores above 0.65 is considered unstable and susceptible to mold and water growth. So with that, this sample here scored at a whopping 0.982. So that's extremely on the high side. So this sample is very high in water activity, right? And then below that, underneath the pictures, we look at a table of the breakdown of the potency of that cannabinoid profile. On the left, we see some of our units, and the top row is what we'll be looking at, because that right there is the percent within the sample. And really what we're all after is to know what total CBD was found in this sample. And here we're at 8.3% and we're at 0.2% THC. So again, we're looking at wet feed from a bale at 71% moisture and about 8.3% CBD. And then we'll go on to the next slide. On this slide here, now we have a dried sample from an IEC Thermo machine. This sample here was dried effectively down to 10.5% moisture content, and that represents a water activity rating of 0.616. So that's below the threshold of molecular activity. And then what we see is the same exact report as the previous one. So right off the top, we can look at our total CBD at 7.26% and our THC right at the same at 0.2%. So overall, what these two reports outline for us is that we have effectively stabilized our hemp and we score pretty solid CBD points, but there is manageable loss seen. So then we'll go on to the following reports. To the terpene reports, yep. So this is really what surprised our team here. We were expecting some CBD degradation, and along with that, we were also expecting terpene degradation in the similar ratios. But what we found was quite the opposite. On the left here, we see a terpene breakdown of the wet baled product. The pie chart we see, the colorful pie chart we see is actually a breakdown of the terpene profile within that sample. So these are percentages of only the total terpene profile. And on the left, the wet sample came in at 0.9% terpene. So then on the right, unfortunately, you can't really, I don't know if you can see it because Chris's some of our cameras are in the way, but the dried sample was dried down to 2.6% total terpenes. And the big thing we also want to note is the fact that both terpene profiles are largely intact. Just at a glance at the pie chart, the ratios that were found in the initial terpene profile are very largely intact. So what this shows to us is that our dryer does a phenomenal job of preserving that terpene profile. What we saw earlier is that there is room for improvement in CBD capture, and with the potential that we see here in our terpene report shows that with further collaboration with the hemp industry and further testing, we feel strongly that we can increase our CBD capture to show similar results what we see here in front of us with this terpene report. So with that, IEC would like to welcome collaboration and testing for further CBD and terpene results so that we can work together to effectively drive our efficiency of this dryer upwards. And with that, we'll proceed with our standard program. Christopher.
Thank you very much, Alfonso. That was a great breakdown of those terpene analysis. I'd like to start off by saying, hi, my name is Chris Ritschel. I'm with IEC Thermo. I worked last year as a field technician, along with my friends and colleagues, Alfonso Delgadillo, as well as Ben Johnson. Between the three of us, we have dried hundreds of thousands of pounds of hemp. So, we consider ourselves to be quite the experts in this field, and we thought that would be really fun to kind of bring into this webinar Wednesday and offer our unique perspective, and not only our unique perspectives as field technicians, but also Alfonso's unique perspective as a chemical engineer. So without any further ado, we will get right to the presentation. Right here we have just a general overview of what we're going to talk about today. To begin with, we're going to talk about the hemp dryer itself and what that consists of, and then the scientific processes that are taking place as the dryer is drying the hemp. We're going to move from there to feed, in-spec feed and out-of-spec feed, and the effects of these things, how to get feed into spec, what out-of-spec feed looks like, and the problems that they can cause. Another thing that we really like to talk about as field technicians is operators. Your operators are the drivers of your dryer. You need to have people that you can trust, that understand the system. So we'll talk about how many dryers or how many operators you'll need for your dryer, as well as the importance of well-trained operators and the learning curve, because it does take a little bit to learn a new system, and you need to give your employees that kind of support. From there, we are going to talk about avoiding issues, what they look like, things like bridging, fiber balls, resin buildup, the rock trap, and basic maintenance. And then we were going to talk about the support that IEC offers. IEC offers technical support beyond the point of sale, which is something that's really special about us in this industry. Most dryer companies, they sell you a dryer, the check clears, and they say, thank you, have a nice day. IEC is committed to the success of our customers. So when you do buy a dryer, what that comes with is the commissioning of the hemp dryer, the training of operators, technical support by phone and also by internet, troubleshooting answers. We do offer retraining as well as advanced technical support and feedback. So we'll break right into it with the flash dryer. The flash dryer itself consists of the flash dryer furnace, the metered feed hopper, the first run of ducting, and the flash dryer cyclone. I'm going to go ahead and toss it right to Alfonso and talk about the process of the flash dry and what that means in the IEC hemp dryer.
Thank you, Chris. So what makes our flash dryer section unique is the fact that we have a very quick dry time met with high temperatures. What allows us to effectively dry in those environments is the fact that we only introduce the highest amount of heat during which hemp has the highest water content, right? So at the start of this process, we do introduce a high heat. It's very quick for about a second to two that it travels through the pre-dryer duct run. But in that moment, right, our water content is upwards at 70% a lot of the times. And when we enter at that high degree, we decrease equally, right? So by the time our hemp has made its way down the cyclone and has already lost a significant amount of water, we're down to about 115 to 130 surface temperature, or 130 Fahrenheit surface temperature of that hemp. So that right there is what makes our pre-dryer technology quite unique.
Awesome. Thank you, Alfonso. So that is pretty much the first phase of the multi-phase drying system. From there, we will talk about the second phase, the fluid bed phase. The fluid bed phase consists of the fluid bed chamber itself, the fluid bed furnace, and the fluid bed cyclone. Once it exits the cyclone, there is also a pneumatic conveyor that disperses product into either super sacks or other containment units. And again, I'm going to knock it right back to Alfonso to talk about the unique fluid bed drying process and the efficiency and such.
Yeah, so the idea here in the fluid bed is that we really want to carry the thermal load that we put in the hemp in the flash dryer throughout in a very evenly manner, so that we never overcook our hemp in the fluid bed, right? So we flash a lot of water content out in the first part of the dryer, and now our water content is about a third of what it was. So our heat in our fluid bed is really roughly at about 150 F when it's operating very efficiently. So right off the bat, we have a lot more careful drying, and our drying times are significantly increased here in the fluid bed. So hemp can traditionally be found in the fluid bed for 30 seconds to about 45 seconds. And while it's drying in there, each molecule of hemp is is somewhat attacked individually. As it's surrounded by warm, dry air, it's dried, and as that dryness occurs, the density of the hemp decreases, and we have that warm air is introduced through a grid, as Drew pointed out in the previous presentation. And with that grid, we create a difference of pressure, creating a lift, and as that density decreases in the hemp, it actually is expelled from the fluid bed, right? So as our hemp is dried, we get lighter in weight and we get expelled from our fluid bed, creating the desired dryness we want. So that's kind of our final touch to the drying process.
Thank you very much, Alfonso. From there, we're going to talk about the PLC and the MCC Control Center. This is going to be the brain of your dryer. This is where all of your parts communicate and talk. This is where you're going to make changes, and this is done through a PLC touchscreen. It's very intuitive. It's constantly updated, but we'll get more into that here in a second. First, we'll go over the screens themselves. This right here is going to be the system control screen. The system control screen is where you're going to monitor the overall status of your system. As you see these different icons appear, these arrows, these gears, and these flames, this will indicate that your system is communicating and working properly. Oftentimes, if there's ever any sort of issue with sort of a backup or something like that, this is where the first indication of that will be. So this is one of the places that I like to pretty much hang out at as I'm running the dryer. Once you get it to a pace that is drying to at the volume you like and at the dryness you want, you can kind of sit at this cruise control screen and make sure everything's moving properly. You never want to just stay on one screen. You kind of want to hop around and make sure that your burner controls are all proper. But this is kind of going to be the cruise control screen. From there, we are going to talk about the motor control screen. The motor control screen is where you're going to control all motor variability. That means anything that you can change on your machine in terms of a motor, the conveyor speed, the fluid bed blower, the ID fans, the load out augers, the fluid agitator. Even oftentimes you can jog additional VFDs here, like a Bale buster, or sometimes I've seen shredders as well. So again, this is where you're going to control any of your motors with any kind of variability. So this is going to be a control screen. And again, this is something that all of your operators are going to want to know. You don't just want to have one person trained on the screen. You want everyone to understand, every aspect of this machine. So from there, we're going to talk about the burner control screen. This is where you're going to set your burner set points. This is going to help you control the level of dryness, as well as more directly the temperature that your dryer runs at. You'll see here we have a graph with two different lines on them. One green one and one red. The red one is going to be your set point, and the green is going to be the actual temperature of the furnace itself. And these will level out over time. Your furnace and your PLC will kind of learn how to communicate better and to reach these set points more effectively and efficiently. So, don't be alarmed when your first one is a little jagged and then they start to smooth out over time. But this is going to be the main burner control screen. This is another place I like to hang out at, just to kind of understand, I'm at about 12% moisture on the back end now. I want to pump it up 3 degrees and bring that down, a couple of points of moisture. So this is basically going to be a temperature control screen, and it's good to monitor this just as a general safety precaution. There's also one more screen, the system control screen. The machine setup screen, and that is going to be more for IEC use when the initial commissioning of your machine. You will have access to it. It will be password protected, but for the most part, unless you know absolutely what you're doing, you probably shouldn't touch it. So from there, I'm going to talk about the lifeblood of the machine, and that's feed. Feed is what makes the technology of our dryer work. Our technology is based on particle size, and it's about surface area. So if we have particle sizes in spec, then the machine works above and beyond what you can imagine. But when you start taking out of spec feed, you start to hurt capacity and you start to create safety issues. And these are just all things that we like to avoid at IEC. And the best answer is to just put your feed into spec. So to kind of explain that a little bit more fully, I'm just going to read this here to you. To reach optimum throughput on our 3 dryer models, they require discrete free-flowing biomass that is approximately 4 mesh or smaller. Now, 4 mesh is approximately 1/4 inch in size. Then the material should have a moisture content no greater than 70%. This feed size can be achieved with harvesting practices, additional sizing with tub and grinder mills, hammer mills and grinders. But it's very important that we get our feed into the proper specifications before we feed it into the machine. This is what makes the machine work. We've been to all sorts of sites, people who, decided that they didn't need to put their feed into spec and they did run at hurt capacities, and that was fine. They're absolutely welcome to do that. But it's not really getting the most out of your dryer when you do that. So, again, we always recommend put the feed into speculation. So to talk a little bit more about that, I'm going to toss it over to Ben Johnson here. He is also one of the field technicians. And he's, in my opinion, seen probably the most different array of ways to put your feed into spec. So go ahead, Ben, take it away.
So yeah, I'm going to touch on really the 4 main ways I saw hemp dealt with at the majority of sites. I'm going to pick 2 types of whole plant and 2 types of wet bale. Those wet bale seem to be the preference, but some people did decide to try whole plant. The first way they tried with whole plant was a wood chipper. While this did shred the plant and get it closer to size, it would not be 4 mesh or smaller, and the fiber would still remain in. We'd still run into quite a few problems. We were able to manage with it, but at a very mitigated rate. A second way that I saw whole plant handled was mechanically bucking it. This was very effective, but it is very labor intensive and requires a very large staff working long hours. If you have the resources to do this, it is a viable option, but after they bucked the buds, they did put it into a knife mill before feeding it to our machine to get it into the 4 mesh spec. From there, the most popular option we ran into this year was baling your hemp. The first way we really saw people trying to feed our system was putting the bales into tub grinders or various bale busters. This would work as long as your hemp was shredded correctly before it was baled. The problems we ran into were within the first 10 to 15 minutes, you would juice the product and really, really tax your dryer. And also we would find an increase in hash buildup with that extra wet material at the very beginning, as well as compacting and creating hash balls that will ride up your belt and won't get completely dry because they're not free flowing. The most successful method we have found has come at one of our centers of excellence, where they break down the bales with a front end loader and then go through a Colorado Mills hammer mill before feeding our system. This hammer mill is very easy to load, very easy to clean, and gets the feed exactly where we want it. You can feed pretty much anything into it and it'll tear it up and put it where it needs to be. And yeah, that's about all I got for feed.
Awesome. Thank you, Ben. So, while Ben was talking, we were sitting here looking at the in-spec feed. I'm going to take you over right here real quick to the out-of-spec feed. This is kind of the stuff that would not be acceptable. This was one of my favorite sites that I've been to. The incredible amounts of fiber, honest things the size of a porcupine, sticks 4 inches long. It's just things that should not belong in the dryer, that are so far out of spec that they cause a safety hazard. So we'll kind of get into that real quick too, and we'll talk about out of spec feed. Anything with long entangled fibers, large wood chips and sticks, large slugs of material. When Ben was talking about wet baled material, that tends to slug together into big balls, particularly at the bottom of the bale. The water seems to collect there. I've even seen, especially those oracles that bale very tightly. I've seen those juice a little bit harder than regular bales as well. So it's just good to keep these things in mind. If you do end up with feed that is well above 70% in moisture, just cut it back with some drier feed before you put it into the dryer. And that's going to cut down your moisture, and it's going to make your drying rate much more efficient. And it's going to give you a better material at the end of the day. So again, inspect feed, fits through a number 4 mesh, is free flowing, free of entanglements, particles no longer than 1/4 of an inch. From feed, the only other thing that matters more than feed, in my opinion, is going to be your operators. Your operators are what drive your car. So we're going to talk about really quickly here, how many operators does a hemp dryer actually require to run? Where should my operators be at during the normal drying operation? What makes a good dryer operator? And how long before my dryer operators are hitting max capacity? A lot of people see a industrial piece of equipment like this and they think it's a whirlpool. You plug it in and you turn it on. Well, that's true. You need to learn how to run it properly, just like with any tool and any especially in the agricultural market. So there's a learning curve for your operators, and it's just important to set the realistic expectations so that you're not putting that incredible pressure on them. Last year in the hemp world was, I don't know if we'll see another one like that. But there was a lot of pressure for everybody, and setting realistic expectations is going to be the best way to kind of minimize that pressure that you're feeling. So from there, we'll talk about how many operators does a hemp dryer require to run? We recommend 4 at training. I would like to have at least 4 well-trusted operators. I don't want 16-year-old kids. I would like somebody above the age of 18, ideally older than that, but it's your machine, and this is your discretion to run your own employees. Then where they should be. I always like to leave 1 at the PLC to make changes as we go through. I like to have 1 loading the metered feed hopper with material, or also monitoring to make sure that our feed is in spec. The 3rd operator I like to put at the end of the fluid bed to make sure there's no buildup within the fluid bed. And also to check the dryness to make sure that we're achieving the proper level of dryness and that we're not, putting away wet hemp, because, that can end up molding and that can end up causing damage. Half the idea of drying your hemp so quickly with a world-class dryer like ours is that you can store this for much longer than you would store anything baled or anything wet. So those are the 4 places that I like to have them at the end to taking care of super sacks and loading and unloading. It's a continuous feed system, so you always want to make sure you have the next super sack ready, and you're not dumping hemp on the floor, because nobody wins with that. So from there, we'll talk about what makes a good operator. In my experience, the best operators have been people who are experienced running systems, agricultural equipment, corn dryers, wheat dryers. These are my favorite operators. They get it. They understand, how to make changes to a system, to wait to see what the changes did, and then, either adjust accordingly or not. And again, it's really important to have somebody with that level of wherewithal running your dryer. It's an expensive piece of machinery, and you wouldn't hire a 16-year-old kid to run your Lamborghini. So beyond that, we can talk about making sure that all your operators are trained on every different position on the dryer. That's super important, again, in my opinion. You need these people to understand why they need to monitor these things, the dryness, the fluid bed buildup, loading the machine properly or making changes on the PLC. All places need to be interchangeable, because these are going to be the people that lead your shifts. And then we also talk about the learning curve. The learning curve is super important to talk about. I usually say it takes 4 to 5 weeks before your operators are all really understanding the system in a way that they can operate it in a max capacity manner. Don't be surprised when the first week or 2, they're drying. You have a 3,000-pound system and they're drying at 2,000 pounds. You know, let them ride where they're comfortable until they can learn to run it up. You know, we will always be there for your support. We all succeed together, and setting that realistic expectation really makes that possible. From there, we'll talk about the responsibilities of your operators, from daily maintenance to things to look out for during operation. To start with, we'll go with daily maintenance. These are just things like all pieces of agricultural equipment and large pieces of machinery that require care and maintenance. No surprise there. Right off the bat, the first thing you're always going to want to do with a dryer system like this, a continuous feed dryer system like this, is make sure that all material from cyclones, conveyor belts, augers, ducting is removed before you finish operating. You don't want to leave something that's going to back up on startup or on shutdown during a cleanup process. You just want to make sure that you're always cleaning up fully before you finish your work. Clearing ducting of resin buildup. You know, one of our favorite things about hemp is that it creates this beautiful resin, and unfortunately, it's very tough to handle. After a couple of hours of operation, you can notice, depending on the moisture content of your product, layers of resin building up on the inside of the ducting. When this happens, it's super simple fix. All you do is you clean it out, either loosen it with a mallet on the outside. There are also regular clean out procedures that are programmed into the machine. If those things aren't clearing it out via a visual inspection, you should take a quick disconnect of the ducting, clean it out by hand. I know it sounds like a lot. It's honestly not. It's 3 screws, and you know, as an operator, you get really good at it really quick. Following proper startup and clean out procedures. Every single time. You know, you can't have people that are letting the first shift or the last shift take care of these things. You want to make sure that you're keeping your machine in tip-top shape all the time. And the way you do that is by following proper startup and clean out procedures, which include removing the resin, also, you know, running through a proper startup and a proper shutdown. With any piece of industrial equipment, you're always going to want to make sure you're checking to make sure the emergency shutoff switches are working. If for any reason you need to shut this thing down, you need to be able to do it quickly. Whether it's some sort of clog or anything, something gets stuck in the dryer, something goes into it that wasn't supposed to. These are all things that you should be hitting the emergency shutoff switch for, and making sure every day that the emergency shutoff switches are working. There's also to clean out the rock trap. The rock trap is going to be right at the bottom of the J-pipe. It's designed because in case something like a rock or something were to make it into our dryer, something that was too heavy to be pulled by the induction of the fans, they would fall down to the bottom underneath the flame of the flash dryer furnace. These usually don't show up, but we brought them in there we brought in the rock trap to make sure that it's a proper clean out every single time. From there, we will talk about a couple of things to look out for as an operator. These are just things to always be looking for. If you see any of these things or any of these things happen, you need to communicate it with your other operators, and it needs to be dealt with immediately. Fiber balls, for one. These are one of the biggest problems within the fluid bed. That's where those tend to build up. If you see large balls of fiber in the fluid bed, you're going to want to stop. You're going to pull them out, and you're going to just start it right back up. It's usually about a 20-second process, doesn't take long, but it can turn into a bigger problem if you don't deal with it immediately. So you always want to be looking out for them. Beyond that, there's catch points and blockages. Those usually don't happen. Those are kind of rare, but as every system is custom engineered, catch points and blockages can happen. We just need to make sure that we're dealing with them appropriately, and either engineering them out of the system or cleaning them out when they do happen. Large slugs of material entering the dryer. The large slugs of material entering the dryer are going to affect the actual drying process. The technology behind our dryer is based on surface area. So if the surface area that it's designed on is 1/4 inch in size, and you throw something the size of a baseball in there, obviously it's not going to dry effectively. And it's going to hurt your input, it's going to hurt your overall dryness, and it's just something we're going to want to avoid. From there, we're going to touch on hash pieces. Now, you've heard us talk about the resin buildup. So when this resin does build up, it does form bricks of hash. And as time goes on, if you do not clean these out, the bricks of hash can accumulate quite large. They can either ignite as the ducting, the air in the duct is quite hot and move through the dryer. And if these things happen, to always follow emergency shutoff procedures and follow your specific fire response procedures. Our new models do have a UV sensor going forward. There are also other fire suppression packages, but always be on the lookout for these things. The beautiful thing about our dryer is that if a fire does occur, it's a continuous feed system. We found that usually it's only about 20 pounds of material maximum that get contaminated, and after a quick clean out, you can continue right forward. These events don't always happen, but they're a fact of life, and we need to be prepared for them. So always be on the lookout for an ember, spark of any kind. And beyond that, you're always going to want to listen to your dryer. Listening to the dryer sounds funny, but when you get into the room with one of these things and turn it on, it honestly, it hums to life. It resonates. So you'll get an ear for what it's supposed to sound like. Any kind of leak in the ducting or a hash brick rattling through, you'll know when something's wrong. So if you hear it, say something, identify what it is, and plan accordingly. To that, we'll talk about IEC's technical support and beyond. Something that I think is really cool about IEC is our technical support. We support you so far beyond the sale. It's fun. It's a lot of fun. So when you buy a dryer, we'll start there. These are what come with it. 2 days of commissioning and fine tuning. This will be us showing up, making sure that the machine's speaking correctly to each other. It's all communicating, it's running properly. The burners are running to the proper temperatures. All the thermocouplings are working properly. And it's just a basic, start it up, make sure everything's working. After that, we also give you 3 days of operator training. This is when an IEC field technician actually comes to your site for 3 days and trains your 4 operators. And again, we please ask you to have a minimum of 4. It's not a bad thing to overstaff your dryer in the beginning. If you want to crank it down as your operators become more experienced, that's a great thing to do. But it's best to be overstaffing it right off the bat. From there, we also offer a week of additional training at our IEC flagship centers of excellence. These places are usually found in Illinois, Wisconsin. I think we do have a couple more coming up this year as well. But depending on your area, that may be an option that you want to look into. Also, one more thing that IEC does that's kind of unique that I think is we're constantly updating our user manuals and guides. This is always done, they're always available digitally, and it's done using your feedback. So as these situations develop and as more dryers are put up across the country, we take the real feedback from these people, from these operators, from these owners, and we put it right back into the machine. And it's really cool. We also offer technical support by phone all the time. Most problems can be solved over the phone. If you do find yourself with an issue that can't be solved over the phone, we do offer an on-site visit from a trained field technician. This is done at an additional fee, along with retraining. That's also offered at an additional fee. But again, these are things that most companies don't offer as when they sell you a dryer. IEC's service is honestly unmatched. And I don't just say that as a field technician, I think that all the time. And that is my webinar Wednesday, friends.
Awesome. Thank you so much, Chris, Alfonso, and Ben. We will have some time for some questions now. So take some time if you're thinking things over, feel free to drop a question in the Q&A below, and we will get to answering those. Our first question we'll answer is from Mike. He asks, do you have mass and energy balances available for review for your dryers? So Alfonso said he's going to answer that, and I'm going to actually share my screen so he can explain something.
Yeah, so unfortunately we don't have full out mass balance calculations that we can make public. The main reason behind that is that we don't know the heat capacity of hemp yet. We're hoping that maybe presenting our initial findings of our CBD and terpene profile test can, start to spark something in our community where, we can work together with various customers and really start to publicly publish this information. So what we do have available for the public is a process flow diagram. And here it pretty much breaks down step by step everything we talked about. The only thing it doesn't have is probably what you're after, Mike, which is, exactly how much energy do I need to drive X amount of water from this hemp. We did calculate when Walter and sat down to design this process, our chief engineer. He did an energy mass balance, but that was all theoretical based off driving essentially pure water. So if we could do that, we could do it with hemp, right? So this system is over-engineered to drive more than enough water out of 3,000 pounds an hour or 6,000 or 15,000 pounds of pure water. So with that, this is all we do have available to the public here, our process flow diagram, and hopefully in a year we can have publicly available mass balances with hard calculations. But for now, this is all we have. And also to answer the previous question, the pre-dryer temperature is usually at about 500. I've been to sites where we can effectively dry at 350 degrees on the front end. But I've also been to sites where, we have to go at like 650 degrees. So it's a variant thing that we have to kind of tackle together. So thank you for that question.
Thanks, Alfonso. Another question we have asks, after changing set points, how long should I expect to see a difference in moisture content at output?
Ben, you want to field this one?
Yeah, I typically like to give it about 10 to 15 minutes before I start to pull samples. If you start to making changes too fast, you're just not giving them time to take effect.
Yeah, and to add with that, the idea there is that we are moving such a massive amount of hemp per hour that when you make a change, you want to make one small gradual change, react to the system, and then move forward. And then from that, every day you go turn on the system, it might take you an hour to hit that cruising altitude, right? Where you're hitting your right parameters and you're drying your hemp to the perfect moisture content on the back end. But you get in there the first week and it takes you an hour and a half to hit that temperature, and then every time thereafter you should get there sooner and sooner. So yeah.
Oh, Jen, you're muted.
Thank you, Chris. All right, another question asks, are there any other hemp dryers with similar technology?
Not that does it all put together like we do. That's kind of the general answer. Anybody else got any pieces to fill in?
Yeah, I think that's actually what makes our technology super unique. Is not only that it's the two phases, but it's the volume at which we do these things. So there are other systems that are relatively similar, but they don't do it at the rate that we do.
Yeah, and no one really does it with the I guess idea of having a stream of hot air. A lot of the technologies out there are kind of having a lot of hemp and then you're forcing air in there, right? We're kind of the other way around, where we have a lot of dry air and few molecules of hemp going through there, which gives us that more faster cure time.
Great, thanks Alfonso and Chris and Ben. Another question we have is from Mike. is there a notable, excuse me, noticeable energy efficiency difference in the different sized dryers? Are the larger ones more efficient?
They're designed to be equally efficient, from my understanding. But however, what we do see is that when you start to buy, you know, a 6,000 and a 15,000, it's your operating costs and everything else involved with drying hemp that really does drive that efficiency up, right? So you're going to have to staff 4 people anyway. You're going to have to buy extra equipment anyway. So if you're already kind of thinking that a 3,000 might be too small or that a 6,000 might be too small, that's why we have a larger option. Because we do feel that when you tackle the whole endeavor of hemp drying at this scale, the larger you go, the more, you know, the higher you drive your efficiency, therefore hopefully creating more profit for everyone.
All right. We don't have any other questions right now. So if anybody has any other questions, feel free to drop it in there right now. Otherwise, we'll get wrapped up for today. You know, and if you do think of more questions after you've kind of processed some of this information, you can either email Alfonso, Ben, or Chris. I can put their contact info back up here, or also you can email info@iecompanies.com. Again, that's info@iecompanies.com. And let's see, yeah, we don't have any more questions, so we'll just wrap it up for today. Thank you so much to Ben, Chris, and Alfonso, first of all, for sharing so much info with us. And thank you to everyone who joined us as well. We're so glad you could be here. If you know somebody who would be interested in learning about hemp drying or IEC hemp dryers, we will have this video up on YouTube later today, and we'll email you all the link as well. And then just be sure to follow us on YouTube and social media for all of the latest news and information. And again, I'm just going to plug next week's webinar because it's going to be a really good one. We have some really knowledgeable hemp farmers who will be on a panel, and we'll be diving deep into lots of things, hemp drying, hemp farming, and lots of good information there. So you can sign up on our Facebook page. We also have links on our website. So thanks everybody, and we hope you have a great week.
Thanks for joining us, everyone.
Thank you for being here.
Thank you, guys. Thank you for bearing with me with my first webinar Wednesday.
You did great, Chris. I'll put their info back up here once more so you can see it if you want to send any emails.
Yeah, and then I would just add specifically for myself, if anybody out there is really open to collaborate on further testing, feel free to drop myself an email, and you know, we're eager to push this industry forward in transparency and, you know, producing information for the general public. So thank you.